Hello everyone. In this video, I will explain the combination of the error, means how the error will propagate. Error means the difference between the true value and the measured value. Sometimes the measurement of the physical quantity will depend more than one physical quantity. For example, we are going to find out density. So the measurement of density depends on the measurement of mass and the volume. There may be some error in the measurement of mass as well as in the measurement of the volume. So overall, what will be the effect on the density due to these errors in mass and volume? So we will discuss such combinations of error in this topic. In first case, if the measurement of the given physical quantity depends on the sum of two similar type of physical quantities. So we will discuss how the error will combine. Let a physical quantity Z depends on the sum of A and B. Let error in A del A and error in B del B. If the error in Z is delta Z, then we can write Z plus minus delta Z is equals to A plus minus delta A in first bracket, then plus B plus minus delta B. In next step, we can write Z plus minus delta Z is equals to A plus minus delta A, then plus B, then plus minus delta B. As we rearrange, then we can write Z plus minus delta Z is equals to A plus B plus minus delta A plus minus delta B. Let in this derivation Z is equals to A plus B as equation 1 and Z plus minus delta Z is equals to A plus B plus minus delta A plus minus delta B be the equation 2. Now if we use equation 1 and equation 2, then we get plus minus delta Z is equals to plus minus delta A plus minus delta B. Now here the maximum possible error will be given by delta Z is equals to delta A plus delta B. So that will be the maximum possible error in this case. Means we can say the maximum possible absolute error in the measurement of Z will be equal to the sum of the absolute error in A and absolute error in B. So the error will be added. Now case 2. When the measurement of the given physical quantity depends on the difference of two other physical quantities. For example, measurement of Z depends on the difference of A and B. So let Z is equals to A minus B. This is equation 1. If error in Z as delta Z, then we write delta Z plus minus, then we write Z plus delta, then we write Z plus minus delta Z is equals to A plus minus delta A minus B plus minus delta. Where delta A and delta B are the errors in the measurement of A and B. Next step, z plus minus delta z is equals to a plus minus delta a minus b plus minus delta b. Then as we rearrange, then we get z plus minus delta z is equals to a minus b plus minus delta a plus minus delta b. Let this is equation 2. We use equation 1 and equation 2. Then we get plus minus delta z is equals to plus minus delta a plus minus delta b. So here the maximum possible error in the measurement of z will be given by delta z is equals to delta a plus delta b. We can say in words, the maximum possible absolute error in the measurement of z will be equal to the sum of the maximum possible absolute error in A and maximum possible absolute error in B. Now case 3. When the measurement of the given physical quantity depends on the product of two other physical quantities. For example, if there is Z is equals to A into B. Now this is equation 1. Within the error limit, it can be written as Z plus minus delta Z is equals to A plus minus delta A into B plus minus delta B. Now next step we will write Z plus minus delta Z is equals to, as we solve this multiplication, we get AB plus minus delta A B plus minus delta B A and plus minus delta A into delta B. In this expression, delta A into delta B will be the negligible quantity, nearly equal to 0. So we can ignore it. So the remaining quantities are Z plus minus delta Z is equals to AB plus minus delta A B plus minus delta B into A. Let this is equation 2. Now divide equation 2 by equation 1. So we get 1 plus minus delta Z divided by delta Z is equals to 1 plus minus delta A divided by A plus minus delta B divided by B. As we simplify, 1 will cancel out. So there is plus minus delta Z divided by Z is equals to plus minus delta A divided by A plus minus delta B divided by B. Now the maximum possible relative error in the measurement of Z. It can be written as delta Z divided by Z is equals to delta A divided by A plus delta B divided by B. So in words we can see the maximum possible relative error in the measurement of Z will be equal to maximum possible relative error in A plus maximum possible relative error in B. Now case 4. When the measurement of the given physical quantity Z depends on the quotient of two other physical quantities, means if there is Z is equals to A divided by B. Let this is equation 1. Within the error limit, we can write Z plus minus delta Z is equals to A plus minus delta A divided by B plus minus delta B. Now in next step, we will write z plus minus delta z is equals to a plus minus delta a, then b plus minus delta b raised to power minus 1. The next step, z plus minus delta z is equals to, here a taken as common, so there would be 1 plus minus delta a divided by a. Then here we consider b raised to power minus 1 as a common, so we get 1 plus minus delta b divided by b raised to power minus 1. Now in next step, z plus minus delta z is equals to a. This can be written in denominator, so a divided by b will be there. Then 1 plus minus delta a divided by a. In this one, we will use binomial theorem and neglecting the higher terms, so there will be 1 minus plus delta b divided by b. Let this is equation 2. Now divide equation 2 by equation 1. So we get 1 plus minus delta z divided by z is equals to, in first bracket, 1 plus minus delta a divided by a, and in second bracket 1 minus plus delta b divided by b. Now solve these brackets. So we get 1 plus minus delta z divided by z, 1 plus minus delta a divided by a, minus plus delta b divided by b, then minus plus delta a delta b divided by ab. In this expression, this quantity is very less, means negligible. So we can write delta a delta b divided by ab nearly equal to 0. So the remaining quantities are 1 plus minus delta z divided by z equal to 1 plus minus delta a divided by a, then minus plus delta b divided by b. As the 1 will cancel out, so there will be plus minus delta z divided by z is equals to plus minus delta a divided by a, then minus plus delta b divided by b. Now here the maximum possible relative error in z can be written as delta z divided by z is equals to delta a divided by a plus delta b divided by b. So in words we can say the maximum possible relative error in z will be given by the sum of maximum possible relative error in A and maximum possible relative error in B. Now in next case, when the results depends on the sum power of a physical quantity. For example, Z is equals to A raised to power n. That this is equation 1. Now within the error limit, we will write Z plus minus delta Z is equals to a plus minus delta a whole raised to power n. Now in next step, we will write z plus minus delta z is equals to a taken as a common, so a raised to power n will be there. 1 plus minus delta a divided by a whole raised to power n. Now next step, z plus minus delta z equal to a raised to power n. To solve this expression, we will use binomial theorem and neglecting the higher terms. So we will write 1 plus minus n delta a divided by a. Let this is equation 2. Now divide equation 2 by equation 1. So we get 1 plus minus delta z divided by z is equals to 1 plus minus n delta a divided by a. The next step, 1 will cancel out, so there will be plus minus delta z divided by z is equals to plus minus n delta a divided by a. So now the maximum possible relative error in z is given by delta z divided by z is equals to n delta a divided by a. We can see in words the maximum possible relative error in z will be the n time of the maximum possible relative error in E. In last case, when the reciprocal of any physical quantity depends on the reciprocal of the sum of two other physical quantities. For example, there is 1 by z is equals to 1 by A plus 1 by B. That this is equation 1. Within the error limit, we will write 1 divided by z plus minus delta z is equals to 1 divided by A plus minus delta A, then plus 1 divided by B plus minus delta B. Now in next step we can write 1 divided by z taken as common, so z in bracket 1 plus minus delta z divided by z will be there. Then 1 divided by A 1 plus minus delta A divided by A plus 1 divided by B in bracket 1 plus minus delta B divided by B. Now next step we will write 1 plus minus delta z divided by z raised over 1 divided by z. Similarly, 1 plus minus delta A divided by A raised over minus 1 whole divided by A, then plus 1 plus minus delta B divided by B whole raised to minus 1 divided by B. As we further simplify using the binomial theorem and neglecting the high terms, we get 1 minus plus delta z divided by z whole divided by z is equals to 1 minus plus delta A divided by A whole divided by A, then plus 1 minus plus delta B divided by B whole divided by B. Now further simplify it. 1 divided by z minus plus delta z divided by z square. Similarly, 1 divided by A minus plus delta A divided by A square and plus 1 divided by B minus plus delta B divided by B square. That this is equation 2. Now as we use equation 1 to substitute the value of 1 by z, then in this whole expression 1 by z, 1 by A and 1 by B will cancel out. So we can write using equation 1. There is minus plus delta z divided by z square is equals to minus plus delta A divided by A square minus plus delta B divided by B square. For the maximum possible error, we will write delta Z divided by Z square is equals to delta A divided by A square plus delta B divided by B square. So using this relation, we can find out the absolute error in such type of. So finally, we can say in all the possible cases, error will be added. There is no subtraction in A error. So that was the combination of error or the propagation of error. Hope all of you are able to understand this concept properly.